पोटेंशियल डिवाइडर्स
Hmm.
पोटेंशियल डिफरेंस को स्प्लिट करता है शायद।
Good,
हाँ।
exactly. Good job. So we're going to start off with topic number 4B, part 3, जिसके अंदर we are going to describe and explain potential divider circuits, make calculations in potential divider circuits, and then explain the uses for the potential divider circuits as well. We have seen that all the voltage supplied by EMFs in a circuit loop must be used by components as potential differences at other points around the circuit loop. जो वोल्टेज आप सप्लाई करते हो वो क्या है? EMF. और वो सारे कौन यूज कर रहे हैं? इट इज यूज बाय कंपोनेंट्स। जैसे कंपोनेंट वन में जो पोटेंशियल डिफरेंस होगा उसको मैं कहूँगा पोटेंशियल डिफरेंस वन। कंपोनेंट टू में होगा पोटेंशियल डिफरेंस टू, कंपोनेंट थ्री में होगा पोटेंशियल डिफरेंस थ्री। और जब मैं इन सबको ऐड करूंगा वो किसकी इक्वल बनेगा? वो मेरे इलेक्ट्रोमोटिव फोर्स या फिर ईएमएफ की इक्वल बनेगा। सो द वे दैट वोल्टेज splits up is proportional to the resistances of the components in the circuit loop as shown in figure B. The voltage across the resistors must add up to 6 volt and the 20 ohm resistor has twice the resistance, so takes twice the voltage of the 10 ohm resistor as well. We call this the potential divider circuit. अब पोटेंशियल डिवाइडर सर्किट में क्या होगा? वोल्टेज स्प्लिट अप होगा डिपेंडिंग ऑन द रेजिस्टेंसेस। व्हाट डू यू थिंक? जहां पे ज्यादा रेजिस्टेंस है वहां पे ज्यादा वोल्टेज या करंट जाना चाहिए, या जहां पे कम रेजिस्टेंस है?
उधर कम रेजिस्टेंस ज्यादा वोल्टेज आएगा।
ठीक है, गुड आइडिया एज वेल, एंड वी गोइंग टू स्टडी कि क्या ये ट्रू है या नहीं। नाउ द वोल्टेज अक्रॉस द टू रेजिस्टर्स मस्ट ऐड अप टू 6 वोल्ट। अगर आपका टोटल ईएमएफ 6 वोल्ट है यहाँ पे, तो जो दोनों रेजिस्टर्स के अक्रॉस वोल्टेज है उन दोनों को अगर आप ऐड करो वो 6 वोल्ट ही बनना चाहिए है। और आप देख सकते हो एक में जब 2 वोल्ट आ रहा है दूसरे में 4 वोल्ट आ रहा है, जब हमने वोल्ट मीटर उसके अक्रॉस लगाया। अब आपने वोल्टेज किसी भी कंपोनेंट के अगेंस्ट मेजर करना है तो आपने सिर्फ उसी के पैरेलल वोल्ट मीटर कनेक्ट करना है। फॉर एग्जांपल अगर ये सर्किट है और मैं कहूँ यार जो यहाँ पे एक बल्ब है ना इसके अक्रॉस क्या है वोल्टेज, तो आप इसके पैरेलल क्या कनेक्ट करोगे? अ वोल्ट मीटर to check what? The potential difference in the bulb only. Now the 20 ohm resistor जो यहाँ पे ये कनेक्टेड है, it has twice the resistance but it has also taken twice the voltage। क्योंकि अगर आपको याद हो V is equal to IR। अब रेजिस्टर अगर ज्यादा होगा तो वोल्टेज भी उसको ज्यादा नहीं चाहिए होगा क्या? इफ द रेजिस्टेंस
जी।
इज 20 ओम, वो वोल्टेज भी ज्यादा लेगा एज कंपेयर टू द 10 ओम रेजिस्टर जो साथ लगा उसमें वोल्टेज कम लगेगा। हाँ, जिसमें रेजिस्टेंस ज्यादा है ना वहां पे करंट कम आएगा और जिसमें रेजिस्टेंस कम है वहां करंट ज्यादा आएगा। बट द लार्जर रेजिस्टर वुड नीड अ लार्जर अमाउंट ऑफ वोल्टेज एज वेल। Ohm law explains that why the voltage is split in proportion to the resistance. Consider the resistances and voltages in figure B in more general terms। हम उसको नाम दे देते हैं। R1 है 10 ओम वाला, R2 कौन है? वो 20 ओम वाला। R1 is the 10 ohm resistor and R2 is the 20 ohm resistor। तो जो R1 का V1 है वो क्या है? 2 वोल्ट्स। और जो V2 है R2 के अगेंस्ट वो क्या है? 4 वोल्ट। और टोटल ईएमएफ आपके पास क्या है? E इज इक्वल टू 6 वोल्ट। ये डाटा समझ आ गया जो लिखे?
जी।
गुड। तो यहां से कहना है कि अगर मैं करंट निकालना है सिर्फ पहले रेजिस्टर के अंदर तो मैं क्या लिखूंगा? आई इज इक्वल टू वी ओवर आर, मतलब कि V1/R1। और अगर मैं आपसे कहूँ कि करंट निकालो इस वाले रजिस्टर में, रजिस्टर टू में, तो आप क्या लिखोगे? I2 इज इक्वल टू V2/R2। अब आप V1 तो नहीं लोगे ना, ना ही आप ईएमएफ से डिवाइड करोगे रेजिस्टेंस को, आपने वही वाला वोल्टेज लेना है जो उसके अक्रॉस गुजर रहा है, क्योंकि इट्स अ सीरीज सर्किट। सीरीज सर्किट जब है आपके पास, सीरीज सर्किट में वोल्टेज हमेशा शेयर होता है। तो वहां से हम दो एक इक्वेशंस बना लेते हैं विच इज V1/R1 इज इक्वल टू V2/R2। या आप इसको ऐसे भी लिख सकते हो V1/V2 इज इक्वल टू R1/R2। आपको पेपर में इनमें से कोई सी तीन चीजें दी होंगी, you'll have to find the fourth one maybe। So the voltage is split in the same proportion as the ratio of the resistances for any values of resistance। This means that for a known EMF supply voltage we can carefully chosen the resistances to share the voltage and provide a specific value of potential difference on one component। If we then also remember that all parallel branches in a circuit must have the same voltage, then any branch that we'll set up in parallel will have the same voltage as well। So we can set up a circuit to provide an exactly chosen voltage of a parallel branch, और पैरेलल में आपको पता है कि वोल्टेज आपके पास सेम होता है, सीरीज में वो क्या हो जाता है, स्प्लिट हो जाता है। गॉट इट? अब
जी।
वेरिएबल रेजिस्टर क्या होता है, आपने पढ़ा हुआ है आईजीसीएस के अंदर, वेरिएबल रेजिस्टर इज दैट समथिंग ऑल्टर्स इट्स रेजिस्टेंसेस। और अगर उसकी वेरी कर सकते हैं रेजिस्टेंस, दैट मीन्स इट कैन ऑल्टर द proportion of the voltage it takes as well. And so the potential difference that is left for the resistance wire can be varied to any value we choose as well. अब यहाँ पे दो कंपोनेंट्स है, पहला कंपोनेंट रेजिस्टेंस वायर है, दूसरा कंपोनेंट वेरिएबल रेजिस्टर लगा हुआ है। अगर इस वेरिएबल रेजिस्टर की लेट्स से यहाँ पे ईएमएफ है 10 वोल्ट, अगर अभी इनमें क्या क्या डिवाइडेड है, 5 वोल्ट 5 वोल्ट, अच्छा, अगर ये वेरिएबल रेजिस्टर, नाउ इट्स अ वेरिएबल रेजिस्टर, इफ द रेजिस्टेंस ऑफ दिस वेरिएबल रेजिस्टर इंक्रीजेस, क्या पता इसका जो पोटेंशियल डिफरेंस है वो 5 वोल्ट से इंक्रीज होके क्या हो जाए, 6 वोल्ट। और जो रेजिस्टेंस वायर है उसका 5 वोल्ट से डिक्रीज होके कितना हो जाए, 4 वोल्ट्स, क्योंकि variable resistor now needs more voltage. So some of the voltage has been taken from the resistance wire to give over here a vessel, और resistance wire का voltage अब कम हो गया है, लेकिन ऐड करोगे तब भी क्या बनेगा, 10 volts. Got it?
जी।
So in order to undertake the investigation to produce these data, potential divider circuit could be used. A variable resistor is set to a high resistance and then it will give a high potential difference, and only a small voltage will be left for the test wire. Now if you further increase the resistance of the variable resistor, then what will happen, क्या पता इसका 6 वोल्ट से 8 वोल्ट potential difference चला जाए, which means that the resistance wire will only have the remaining voltage, which is 10 minus 8 is equal to 2 volt. बट अभी भी आप अगर सम करोगे दैट विल स्टिल बी इक्वल टू 10 वोल्ट. So if you keep increasing the resistance of the variable resistor, the share of EMF or the potential difference will be more to the variable resistor as well. By decreasing the resistance of the variable resistor, the potential difference across the test wire will increase. अब अगर मैं वेरिएबल रेजिस्टर की लेट्स से रेजिस्टेंस को डिक्रीज कर देता हूँ, दैट मीन्स इसका पोटेंशियल डिफरेंस भी डिक्रीज कर जाएगा, विच मीन्स कि रेजिस्टेंस वायर इज नाउ गोइंग टू गेट अ लार्जर शेयर ऑफ द ईएमएफ, विच मीन्स द रेजिस्टेंस वायर विल नाउ गेट अ larger potential difference as well. So that's where we are going to talk about the potential divider equation. As the potential divider in a, as in a potential difference in a potential divider circuit is split in proportion to the resistances of the components, हमेशा याद रखो potential difference split कैसे होगा, on the basis of resistances, कितना potential difference किसके पास जाना है, that is all going to depend on the resistance as well, and we can calculate the potential difference across them mathematically as well. Now here you can see we have the total input. This is known as V input, that we also call as EMF. The V input is 12 volt. R1 is 100 ohm. R2 is 500 ohm. R1 के against potential difference would be known as V1. R2 के against potential difference would be known as V2. Now, यहाँ पे आप देख सकते हो that these are known as the output potential differences as well. In the circuit diagram of figure D, we have a general terminology for the values used in calculations of a potential divider circuit, जैसे V output है, R1, R2 and V input. And using these, we can calculate the potential difference across the component of the interest. Now, which one is the component of interest जिसके अगेंस्ट आप V आउटपुट मेजर करना चाहते हो? अगर आपने V2
हाँ, 10 वोल्ट है। जी।
हाँ, नहीं नहीं अभी हमें नहीं पता कितना है, ठीक है। इफ यू वांट टू कैलकुलेट द V2 एज योर इंटरेस्ट, अब आपका इंटरेस्ट किस में, आपने V1 निकालना है, V2 निकालना है। अगर मेरा इंटरेस्ट V2 है, आई विल कॉल दिस व्हाट, द V आउटपुट। गॉट इट?
ओके।
If I am interested in finding the potential difference V2, then I will call my V2 as V output. और वहां से हमारे पास एक इक्वेशन निकलेगी। अब V आउटपुट हमने किसको कहा था, V2 को। तो V आउटपुट इज इक्वल टू V इनपुट इंटू R2 ओवर R1 प्लस R2. बट इफ माई इंटरेस्ट वॉज इन V1, आई वुड कॉल V1 एज द V आउटपुट। तब क्या इक्वेशन बनती, V आउटपुट इज इक्वल टू V इनपुट मल्टीप्लाइड बाय मेरा V आउटपुट, अब इस दफा इंटरेस्टेड था V1 के अक्रॉस, आई वॉज इंटरेस्टेड टू फाइंड द पोटेंशियल डिफरेंस अक्रॉस V1। तो वहां पे मैं न्यूमरेटर में भी R1 लूंगा इंस्टेड ऑफ R2, सो R1 ओवर R1 प्लस R2। गॉट इट?
सही है।
and that is how you are going to get the 10 volt like you suggested as well, depending on आपने कौन सा निकालना चाहते हो, V1।
तो क्या रेशो के हिसाब से भी निकाल सकते हैं? नहीं, मैंने तो
नहीं,
ऐसे
इट
किया।
वोंट, और नहीं, हर दफा वर्क नहीं करे, अभी कर रहा है लकीली।
नहीं
अगर आप
नहीं, हाँ
देखो वन
अभी
रेशो
हर
फाइव से
हमेशा नहीं
अभी कर
होगा।
रहा है, हर दफा नहीं करेगा। ठीक है।
ओके।
यस। क्योंकि कभी कभार वेरिएबल रेजिस्टर आएगा, थर्मिस्टर आएगा, रेजिस्टेंस वायर आएगी,
बिल्कुल।
कंडक्टर आएगा, तो वो इट्स नॉट ऑलवेज गोना वर्क। बट यस, रेशो वाला प्रोपोर्शन तरीका लें तो आईजीसीएसई में हम रेशो से ही निकालते थे। अभी इफ यू आर
लेकिन आपने
फाइंडिंग
आप
V1, आप इसको क्या नाम दे दोगे? वी आउटपुट का।
वी आउटपुट।
और आप रेजिस्टेंस 1 लोगे न्यूमरेटर में। अगर आप इंटरेस्टेड हो वी
ओके।
टू निकालने में, यू विल कॉल दिस द वी आउटपुट, और न्यूमरेटर में फिर आप उसी का रेजिस्टेंस लोगे। इफ वी टू इज द वी आउटपुट, देन R2 डिवाइड बाय R1 प्लस R2। दिस इज व्हाट अ potential divider या potentiometer is used in। और the idea of using a potential divider to supply a variable voltage as required has been incorporated into an electrical component called the potentiometer। इट इज अ मूवेबल कॉन्टैक्ट जो कि स्लाइड कर सकता है ओवर अ फिक्स लेंथ ऑफ रेजिस्टेंस वायर, एंड इट एडजस्ट्स द लेंथ दैट इज ऑन आइदर साइड ऑफ द वाइपर एज वेल। पोटेंशियोमीटर ना अपनी एक वायर है, पोटेंशियोमीटर अपनी जगह भी चेंज कर सकता है। एक हम उसको स्लाइड करके एक जगह पे ला सकते हैं, वी कैन चेंज द स्लाइड अगैन एंड ब्रिंग इट टू अनदर प्लेस एज वेल। दैट इज हाउ दिस potentiometer would actually work. The two lengths of the wire are the two resistors in our potential divider circuits and adjusting their relative lengths। अगर ये एक पूरी वायर है, इसकी रेजिस्टेंस है 10 ओम। अब मेरे पास एक पोटेंशियोमीटर है जो कि यहाँ से कनेक्टेड है, और ये एक तार आ रही है। अगर मैं अभी इतना सा हिस्सा लूंगा, मतलब कि आई माइट बी यूजिंग ओनली 4 ओम। मैं इसको ना, अब ये स्लाइडिंग कॉन्टैक्ट है, इसको उतार के थोड़ा सा मैं स्लाइडिंग कॉन्टैक्ट को मूव भी कर सकता हूँ। कैसे? अब मैं इसी स्लाइडिंग कॉन्टैक्ट को थोड़ा सा मूव करके यहाँ पे कनेक्ट कर दूंगा। अब मैं 10 ओम से कितनी रेजिस्टेंस यूज कर रहा हूँ? शायद 7 ओम। अगर मैं इसको यहाँ कनेक्ट कर दूं तो मैं शायद 9 ओम यूज कर रहा हूँ इस वक्त। दिस इज नोन एज अ potentiometer। By adjusting the relative lengths of the sliding contact, I can actually choose my own resistance as well। And that is how these potential dividers are used in sensor circuits as well। जो कि सेंसर कंट्रोल सर्किट्स होंगे, जो एक बल्ब को ब्राइट करें, लाइट करें। कभी आपने देखे वो बहुत से एक ब्लूटूथ लाइट्स आती हैं, जिनको आप, एक तो होता है ऑन हो रही है, ऑफ हो रही है लाइट, एक होती है डिम हो रही है, ब्राइट हो रही है। वो कैसे एडजस्ट होती है? पोटेंशियोमीटर। कुछ घरों में वो आपके पास
लेकिन पोटेंशियोमीटर और वेरिएबल रेजिस्टर का फर्क क्या होता है?
हाँ, गुड क्वेश्चन। वेरिएबल रेजिस्टर के अक्रॉस यू हैव टू मेजर दी वोल्टेज एज वेल। वेरिएबल रेजिस्टर जो है वो आपके पास एडजस्टेबल ज़्यादा नहीं होता। वेरिएबल रेजिस्टर की आपको पोटेंशियल डिफरेंस वेरी करना पड़ता है। यहाँ पे हम स्लाइडिंग कॉन्टैक्ट मूव कर सकते हैं बाय वेरिंग द रेजिस्टेंस, जो पोटेंशियल डिफरेंस को चेंज करेगा। गॉट इट?
मतलब फिजिकली।
यस। ठीक है, हम उसका स्लाइडिंग
ओके।
कॉन्टैक्ट को मूव करेंगे इधर से उधर, तो वो डिम कर रहा है और ब्राइट वाली भी आपको ऑप्शन दे रहा है इन अ सीरीज सर्किट। अब फिगर जी में द लैंप इज इन पैरेलल। यू कैन सी ओवर है, जो लैंप है वो एक पैरेलल में लगा हुआ है विद द एलडीआर, सो विल बी पावर्ड बाय द सेम वोल्टेज एज द क्रॉस द एलडीआर एज वेल। The resistance of an LDR increases if the ambient light level drops, and darker surroundings would make the resistance go up। हमें पता है कि लाइट जब कम पड़ती है, resistance ज़्यादा होती है in an LDR as well, and in bright conditions LDR will have a low resistance। So it will take a very small proportion of 12 volt EMF to supplied by the battery। मतलब कि लैम्प बहुत डिम हो जाएगा, probably so much that वो शायद ऑफ ही लगे। as conditions become darker, एलडीआर की रेजिस्टेंस बढ़ जाएगी, तो 12 वोल्ट ईएमएफ में से ज्यादा प्रोपोर्शन अब मिलेगा बल्ब को, और जब बल्ब को ज्यादा प्रोपोर्शन मिलेगा इट विल बिकम ब्राइटर। गॉट इट?
जी, लेकिन एलडीआर के अंदर क्या होता है, वेरिएबल रेजिस्टर?
एलडीआर के अंदर कुछ डिटेक्टर होते हैं। लेट्स से अभी ब्राइट कंडीशन में क्या होगा, एलडीआर के ऊपर लाइट पड़ी है, लाइट जब बढ़ेगी रेजिस्टेंस कम हो जाएगी। जब रेजिस्टेंस कम होगी तो वोल्टेज क्या हो जाएगा? कम। और जब वोल्टेज कम
जी।
हो जाएगा तो बल्ब क्या हो जाएगा? डिम।
ऑफ। तकरीबन ऑफ ही
जी।
होगा।
अब एलडीआर के ऊपर लाइट नहीं पड़ी, लाइट कम हो गई है, रेजिस्टेंस ज़्यादा हो गई है, मतलब कि वोल्टेज भी ज़्यादा हो गया है, बल्ब क्या हो जाएगा? ब्राइट।
ब्राइट।
दिस इज हाउ दोज सेंसर डिवाइसेस ऑल्सो वर्क, जो कि आजकल बहुत से लोगों ने घरों के बाहर लगाना शुरू कर दिए हैं, क्योंकि लोग नहीं चाहते कि हम रात को आके अपने पोर्च की लाइट ऑन करें या ऑफ करें। वो क्या लगा देते हैं, सोलर वाली। सोलर वाली लाइट भी ऐसी ही काम करती है, जैसे ही सुबह होगी, सूरज निकलेगा, जो आप रात को लाइट जला के गए थे अपने घर के बाहर, वो खुद ही धूप से बंद हो जाएगी। गॉट इट?
जी।
जैसे ही अंधेरा होगा बाहर, क्या होगा, आपको खुद जाके ऑन करनी पड़ेगी? नहीं। जैसे ही अंधेरा होगा, लाइट कम होगी, रेजिस्टेंस ज़्यादा होगी, वोल्टेज ज़्यादा होगी, लैंप जल जाएगा, आपका ब्राइट हो जाएगा। गॉट इट?
ओके।
ये इनको हम सेंसर पोटेंशियल डिवाइडर्स का भी नाम देते हैं। सो पोटेंशियल डिवाइडर इज अ सर्किट डिजाइन टू प्रोवाइड स्पेसिफिक वोल्टेज वैल्यूज बाय splitting an EMF across two resistor, and a potentiometer is a version of the potential divider in which a single resistance wire is used in two parts to form two resistances, और एक sliding connection होता है that can be adjusted to alter the comparative resistances and the output potential difference from the potentiometer as well. Got it?
जी।
All right.
Hi guys! In this video we're going to be looking at potential dividers, the potential divider equation, and we're going to finish with a summary. So we're going to start off by looking at potential dividers. And what potential dividers are is it's essentially a way of setting up a circuit so that the EMF from a power supply can be split between different components. So now let's have a look at this in more detail. Power supplies, such as batteries, have a fixed EMF. So we have a battery here, which is quite often the power supply for a circuit, and this battery has a fixed EMF that we can't change. Sometimes devices need to vary their potential difference when connected to a source with a fixed EMF. So for example, going back to our battery, components are connected to our battery. But this is a fixed EMF source, so we can't actually control the EMF of the battery. So if we want a different EMF than the one supplied by the battery, we have a problem. An example of such a device is a speaker. So here we have a speaker, and a speaker is connected to a power supply in order for it to play music or to play a sound. However, in order to vary the volume of a speaker, we need to vary its potential difference. So quite often when we use a speaker, we don't want it to be at a fixed volume. We want to have the flexibility to change the volume. And we actually need to vary the potential difference of the speaker in order to vary the volume. And then in order to vary the potential difference, we need to vary the EMF. But the EMF of a battery is fixed, and it's quite inconvenient to have to keep changing the battery for different EMFs in order to vary the potential difference and to vary the volume. So since speakers often contain batteries with fixed EMFs, we must add an additional feature to the speaker's circuit to vary the potential difference. So rather than having to change the battery that's supplying the fixed EMF, we add an additional feature in order to vary the potential difference, because otherwise
अब आप चाहते हो कि हम पोटेंशियल डिफरेंस को वेरी करें, और पोटेंशियल डिफरेंस को वेरी करने के लिए नाउ यू आर गोइंग टू ऐड अनदर कंपोनेंट व्हिच इज नोन एज अ पोटेंशियल डिवाइडर। गॉट इट?
जी।
गुड।
EMF of the power supply. So the power supply here, our battery, has a fixed EMF. And what a potential divider circuit does is it divides the potential difference. So this is a typical potential divider circuit setup. So the potential divider circuit divides the EMF across these two components. So we have V1 here and V2 here. So this is convenient then, because it means the potential difference across one of the devices isn't equal to the fixed EMF. It means we can have other values. And in this case, the EMF is equal to V1 plus V2. And we know this from Kirchhoff's second law. So we've said that in a closed loop, the sum of the EMFs, which in this case is just the EMF of that battery, is equal to the sum of the potential differences across the components in that closed loop, which in this case is just V1 plus V2. A potential divider circuit contains two or more resistors in series with a source of fixed EMF. So here's our battery, which is our source of fixed EMF. And then we've got two resistors in series. And because these resistors are connected in series, we're able to split the EMF across the two resistors. And again, we get this from Kirchhoff's second law. The EMF of the power supply is denoted as Vin. So in this case, the EMF of the battery here is denoted as Vin. So that's the potential difference in, or the voltage in. And we've said that as the resistors are connected in series, following Kirchhoff's second law, the EMF of the source is split between them. So the EMF of the source we've said is Vin, and then we get a potential difference across each resistor. So we have V1 and V2. And we've said that Kirchhoff's second law tells us that the sum of the EMFs in a closed loop is equal to the sum of the potential differences across components in that closed loop. So the sum of the EMFs in this case is just Vin. So our EMF source is the battery, and we've said the fixed EMF of our source is denoted as Vin. So that's what the sum of the EMFs is here. And then the sum of the potential differences is just the sum of the potential differences across the two resistors. So that's just V1 plus V2. The resistors can have a potential difference of any value from 0 up to the maximum supplied from the power source, so long as they add to Vin. So we said Vin is our fixed EMF, and the values that V1 and V2 can take can be anything between 0 and Vin. However, the one condition we need to satisfy is that Vin is equal to V1 plus V2. So for example, if V1 was equal to Vin, that would mean that V2 would have to be 0 and vice versa. So the sum of the two must be equal to Vin, and then other than that, V1 and V2 can take any value between 0 and Vin. And the reason this is the case is from Kirchhoff's second law. So Vin must always be equal to V1 plus V2, and we get that from Kirchhoff's second law. For example, two resistors connected in series to a 12-volt supply can give us a potential divider circuit. So if our supply is 12 volts, that means Vin is equal to 12 volts. And then we've got two resistors, so they probably have resistances R1, R2. And in this case, V1 and V2 can each take any value from 0 to 12, as long as they add up to 12. So for example, V1 might be equal to 4 volts, and V2 might be equal to 8 volts. And then when we find Vin by doing V1 plus V2, we've just got 4 plus 8, which is 12 volts. So that works. So we can see why this is a potential divider circuit. The fixed EMF is 12 volts. However, when we look at the potential difference across our components, we can see that it's been split. So we have a different value to the fixed EMF that goes into the circuit. A circuit can then be connected across one of the resistors in parallel. So again, we've got Vin here, which we said was 12 volts, and then we've got R1 and R2, and we said the potential difference across R1 was 4 volts, and the potential difference across R2 was 8 volts. So now we can connect a circuit across one of the resistors in parallel. So that's what we've got here. So here we've got Vin, 12 volts, we're just not showing that on our diagram. Then this is R2, which we said has a potential difference of 8 volts, and then R1 with a potential difference of 4 volts. And then this value here is V out. So what we mean by V out is the value of the potential difference that we get by splitting up the EMF, and that's from using two resistors. So V out, for example, is our desired potential difference. So for example, the potential difference we want for a speaker in order to ensure we have the correct volume. The potential difference across that circuit, which is V out, is given by the potential difference across the resistor it is connected in parallel with. So V in we said was 12 volts, and then we said we've got R2, R1, and we've got 8 volts, 4 volts. So in this case, V out, so that's the potential difference that's supplied to the circuit, is given by the potential difference across R1 here. So that's just equal to 4 volts. By using resistors of different fixed resistance, we can vary the potential difference across the connected circuit from 0 to the maximum value of the power supply. So V in, we've said, is the value of our power supply, and then we've got two resistors, R2, R1, and we've said previously that if we have V2 here and V1 here, V1 and V2 can take any value from 0 to V in, provided that they add up to V in. And in this case, we've said that V out is equal to V1. And if V1 is between 0 and V in, that must mean V out can also take any value from 0 to V in. So this is essentially how a potential divider works. By using two resistors in series, we're able to split the EMF provided by the source into two different potential differences in order to get a particular potential difference we want for a circuit. So now that we understand what a potential divider is and also how it works, we're going to look at how we can derive the potential divider equation. For a power supply with a fixed V in, we can determine the resistances required to produce a desired V out in a potential divider circuit. So the EMF provided by our power supply is our V in. That's the potential difference coming into the circuit. And we've seen that in a potential divider setup, we connect two resistors in series. So we've got R1 and R2 here. And if we connect a circuit across one of the two resistors, in this case R2, we get a potential difference across that circuit equal to the potential difference across that resistor. So in this case, the potential difference across R2 is V out, and that's the potential difference supplied to that circuit. So in order to get a particular value for V out that we want, we need to select certain values for R1 and R2. So the resistances of the resistors affect potential difference across our connected circuit. We know that the total resistance of resistors connected in series is given by the sum of their individual resistances. So the total resistance R of a series circuit with lots of resistors connected in series is just the sum of their resistances. So we've got R1 plus R2 plus R3 and so on, depending on how many resistors we have. For a potential divider circuit containing two resistors of fixed resistance, we can write the total resistance of the combination. So going back to our potential divider circuit, we've got two resistors connected in series. We've got R2 and R1. So to get the total resistance of this circuit, R, we just sum them together. So we've got R1 plus R2. We also know from Kirchhoff's second law that the potential difference across the power supply is equal to the potential difference across the resistors. So V in is the EMF of our power supply. And we know from Kirchhoff's second law that the sum of the EMFs in a closed loop is equal to the sum of the potential differences across the components in that loop. So in this case, the sum of the potential differences of our component is the potential difference across the two resistors. So that's why V in is equal to the potential difference across the resistors. From the equation relating current, potential difference, and resistance, we can write an expression for the current through the circuit. So we know that the total current going through this series circuit is given by the total potential difference of the circuit, so that's the potential difference across the resistors, divided by the total resistance, so that's the combined resistance of the two resistors. So we can actually write this in terms of our symbols. So we know that the potential difference across the resistors is equal to V in from Kirchhoff's second law, and we've already found an expression for the total resistance of the circuit. So we found that that was R1 plus R2. We can multiply both sides of this equation by the resistance of the resistor the output is connected to get the potential difference across the first resistor. So remember, potential difference is R times I. So to get the potential difference across our first resistor, we just do R1, its resistance, multiplied by the current going through it, which is I. So this is just going to be equal to R1 multiplied by the expression we just found for current. So we found that that was V in divided by R1 plus R2. So we now have an expression for V1 because R1 times I is just V1, the potential difference across that resistor. So V1 is equal to R1 divided by R1 plus R2 multiplied by Vin. And we can also do the same for the potential difference across the second resistor. So now we're going to do R2 multiplied by the current. So this is going to be equal to R2 multiplied by our expression for the current, which we found was Vin divided by R1 plus R2. So R2 times I gives us V2, the potential difference across the second resistor. So now we've got an expression for that potential difference. We have R2 divided by R1 plus R2 multiplied by Vin. We see that the potential difference across each resistor in a potential divider circuit is given by its fraction of the total resistance multiplied by the potential difference of the power supply. So looking at our expression for V2, we can see we've got V2 multiplied by R2 divided by R1 plus R2 and then multiplied by Vin. So V2 is the potential difference across the second resistor, and then R2 over R1 plus R2 is the fraction of the total resistance for R2. So we've got R2, the resistance of the second resistor, divided by the total resistance in the circuit. So we can see why we've got that fraction. So then to get V2, we just do that fraction multiplied by the potential difference of the power supply. So that's how we can break down this expression. We know that when a circuit is connected across one of the resistors, the total potential difference in the circuit is equal to the potential difference across that resistor. So we've said the EMF provided by the power supply is Vin, and we've got two resistors in series R1 and R2, and they each have a potential difference across them. So we've got V1 and V2. So if we were to connect a circuit across R2 in order to get a certain potential difference for that circuit, whatever the potential difference across R2 is will be equal to the potential difference across that circuit. So that's what V out is. V out is equal to V2.
So this is known as the potential divider equation. Got it?